In a previous video we saw the progress made by Spot, the robodog by Boston Dynamics that went from a remote-controlled puppy to an autonomous dog powered by ChatGPT. Spot and other quadrupedal robots are getting smarter. They have excellent balance and they are good at navigating rough terrains. However, these robodogs still have limitations. They struggle with tasks humans perform every day. They lack the ability to manipulate large or heavy objects, especially in cluttered real-world environments, and they don't work well in teams. Big tech companies are now tackling this issue, and they showcased their results in papers presented at ICRA 2025, one of the most important academic events about robotics. Google, for example, has a trick for helping robodogs move large objects. If one robodog can't do it alone, then have multiple robodogs work together. Google is training these robodogs to coordinate as a team to handle tasks that even bigger robodogs cannot do alone, like moving obstacles. In the process, the robodogs improve features like whole-body coordination and develop long-horizon planning, which means that they can look beyond the next immediate step and plan for the full sequence of actions needed to achieve a goal. Google is testing the concept with robodogs by Unitree. It's smaller than Spot, but agile, robust and, more importantly, much cheaper. Google is also teaching to jump continuously instead of just hopping to avoid obstacles. This type of motion helps the robodog gain speed, adapt to uneven terrain and move more like a real-life quadruped. Google is also equipping them with advanced AI tools, making C1 a serious competitor to Spot. ByteDance, the parent company of TikTok, also has its eyes on robodogs. At ICRA 2025, researchers from ByteDance presented the concept of a robodog designed to be more independent than other models. The company is developing a dog that can learn to walk using only its own sensory input, like vision and proprioception, a big word that indicates the sense of someone's body's position and movement. Normally, these types of information are passed on by bigger models that have so-called privileged information. These include high-quality maps, very reliable sensor data, or high-fidelity physics of the environment. These high-quality data are not always available, are generated through simulation, and therefore do not address all situations of the real world. The robodog under development at ByteDance can predict the outcomes of its decisions and adjust its behavior over time, like figuring out how to jump over a puddle after a few attempts. This makes the robot more flexible, independent, and better at handling real-world environments where perfect information does not exist. A team of Korean companies and institutions is using a similar approach to develop robodogs that could significantly improve mobility and safety for people who are visually impaired. This is a robodog that can understand its surroundings and, more importantly, describe them to its human companion, something that a living dog cannot do. The Korean solution uses a more advanced model than ByteDance's version and can handle more complex situations, such as safely crossing a street. We first met Aibo, Sony's robodog, a few years ago at CES. It was designed as an interactive companion to engage and delight its owners. Since then, Sony has continued to update Aibo with better sensors, smarter AI for recognizing faces and voices, and even new tricks through software updates. Now Aibo is being trained to do something no real dog would do: dance. Dancing is recognized by researchers as one of the most effective ways to attract human attention and express robotic emotions through movement. However, existing approaches to robo-dancing have serious limitations. Most robots today perform pre-programmed moves based on fixed rhythm patterns, a routine that AI researchers called frequency domain representations. These limit how expressive, smooth, and flexible the dances can be. And this also makes it hard for a robot to do other tasks, like walking or making eye contact while dancing. Now Sony is equipping Aibo with a new model called Deep Fourier Mimic, or DFM. This learning method removed the rigidity of the previous model based on frequency domain control. With DFM, Aibo can learn more expressive, lifelike dance moves, switch smoothly between dance styles, and even add extra steps, like moving around and looking at the audience while dancing. The new Aibo can also adapt its dance in real time, instead of just replaying preset routines. Greater human engagement and emotional response are important because this lays the groundwork for using similar techniques in therapy robots, public performers, or next-generation robopets. All the robodogs we talked about so far rely on specific hardware and a fixed set of sensors that gather data, like joint angles, body position, or speed. If a sensor breaks or differs from what the robot was trained on, the walking software often stops working. In other words, the model used today to perform walking in a robodog is designed for one specific robot and sensor set, which means that it doesn't adapt well to new robots or unexpected situations. And this is where NVIDIA comes in. NVIDIA in fact is working on a more flexible solution called MSTA, which stands for Masked Sensor Transformer Architecture. The MSTA is an AI model based on a transformer, a deep learning framework famous for handling sequences like text, audio, or in this case, robot data. This is how it works. NVIDIA's system breaks down sensor data into tokens. Each piece of data, like joint angles or speed, becomes a token, like a word in a sentence. During training, parts of this data are masked or hidden, forcing the model to learn to predict the missing pieces. This strengthens the understanding on how the robot's body works as a whole, a system that, as we saw before, is called proprioception. The masking tricks makes the transformer smarter at choosing which data points matter the most for the task. For example, figuring out the target position of each joint to move the robot's legs naturally. The result is a walking software that truly understands the robot's movements and can adapt to different sensor setups. In summary, robodogs don't bark, wag, or cuddle, but they can learn, work together, and even dance. They will never replace real dogs, but with the right prompts, they might still become your next best companion.